Question 88 from it is June 2020 mathematical science paper. Let P be an odd prime such that P is 2 mod 3 and F be the field with P elements. So consider the subset E of Fp cross Fp given by X and E, given by this E, where E is the X comma Y. This belongs to the Fp space, and the equation is y square is equal to x cube plus 1, right? So here we can, if we consider, so let us consider the which of the following as true. So we have to find the number of elements. So let us consider P equal to 5. So if P equal to 5, then it is so putting it over here, so 5 equal to this equivalent to 2 mod 3, right? Divided by 3, it gives the remainder 2. So we have f of 5 is equal to the z5. So the elements of it will be 0, 1, 2, 3 and 4. So then E will be x comma y as we have written. So it will be z5 cross z5, and the equation is y square is equal to x cube plus 1. So elements of E are, so what are the elements of E? What are the elements of E? It will be, first one will be 0 comma 1, because 1 square is equal to 0 cube plus 1, and 2 comma 3, so which means that the y square is 3 square plus equal to 2 cube plus 1. So these are the two elements. So E is equal to the 0 comma 1 and 2 comma 3. So E has two elements. In our case, the option 1 is correct, right? So since E has two elements, which means that, let us consider the option E, the option 4, that is E has at least 2p elements. 2p means 10. So this number of elements is less than 2p, right? So which is 10. So the option 4 is incorrect, because E has only 2 elements in it, and option 2 is E has at most 2p elements, and E can have p square elements. So option 2 and 4 is incorrect. So let's option 1 4 is incorrect. Okay, so now check with the option 3. So it is saying that the statement can have p square. Okay, so p square means it will be 5 square, that is 25 elements it is saying. So 25 elements, which will be wrong. It is not possible for E to have p square elements, because if it is correct, then this x comma x, what you have given, the same value, the p equal to e square, this belongs to E. So x square is equal to x cube plus 1, which will be a contradiction. Okay, so in our case the option, so then what will be the total number of elements in that case will be z5 cross z5, that is 25, which will be a contradiction. So option 3 is incorrect. So we have only option 1 and 2. These are the two correct options. E has at least 2 elements and E has at most 2p elements. Question 89. Consider the subset of R2 defined as follows. So we have been given that A of is xy, which belongs to the space R cross R, and x minus y, x minus 2, y minus 3, and y plus 4 equal to 0. Which of the following statements are true? So the set A is given by, so let's draw a axis first of all. Okay, so this is the primary axis, the main axis. So we have x minus 1, x minus 2. So which one will be the x minus 1 equation? So this is the, at x equal to 1, the straight line is, okay. Similarly for this 2, it is x equal to 2. Okay, now y equal to 3, so we can put it over there as this is y at 3, and we have just at this point of time you may ignore the scaling. So this is y equal to minus 4. So this is the set A is given by this, right? So we have made the problem much more simple, and now we will see one by one. Suppose that now say that A is connected. First option, whether to check. So clearly you can see that A is the union of 4 lines, right? So A is the union of 4 lines over here in R square plane. It's R2 actually, yes, x and y. So each line is connected and intersection is non-empty. So union of these 4 lines is connected. So from here we can say that A is connected. That is a correct option. Option 1 is correct. Let's check with the option 2. A is compact. First of all, we have to know that A is not bounded. Okay. A is not bounded in our case. So there is a theorem which states that if A is not bounded, the theorem is Heine-Borel theorem. Heine-Borel you can say theorem. That A is not bounded, then A is also not compact. The theorem states. So option 2 is false. We are not going into the details of this Heine-Borel theorem. Okay, let's check with option 3 whether A is closed. So since graph of any continuous function is closed, so we can write that graph of any continuous function is closed, then graph of x equal to 1, x equal to 2, y equal to 3, and y equal to minus 4, they are also closed, right? So the its union of A is also closed. So the finite union, since we know that finite union of closed sets are closed. So A is also closed in our case. So option 3 is correct option. Okay. And last one is the A is dense. Okay, let's check with the option 4. So whether A is dense or not. So we know that A of complement or A bar, we can write this as A union A prime. A union A complement, which is simply A union A, and it is nothing but A. Since we have written that A prime is equal to A, as A is closed, right, then A complement is not equal to the R2. So A is not dense in R2. So option 4 is not correct. So A is not dense. Option 4 is not correct. So for dense we must have this A complement belongs to this space of R2. So in our case, what are the correct options? So A is connected. Okay, A is connected. This is the correct option we got. But A is not compact and A is closed. So 1 and 3, these are the two correct options.